Hello all Form 3 students. In this video, we'll talk about 7.3, 5 other kinds of quadrilaterals mentioned in your book. As I know some of you don't have your textbook at home, so I'll upload this PowerPoint from Oxford to the Google Classroom, so you may take a look at it. Okay, so let's introduce 5 of them. The first one, rhombus. In Chinese, we call it 菱形. And the second one, rectangles, 长方形, square, 正方形. And the other two, the first one is trapezium, means 梯形. And the fifth one, kites, means 繞形. I know some of you may learn about them in primary school, but maybe in this video, we'll talk about them in depth and maybe a little bit different from what you learned in primary school. So, the first one, rhombus. For any quadrilaterals with 4 equal sides, we can call it a rhombus. So this is the definition of rhombus. Whenever you see any quadrilaterals with 4 equal sides, you may say that, okay, this is a rhombus. And one more thing, according to what we learned in 7.2, for any quadrilaterals with 2 pairs of equal opposite sign, for rhombus we have, okay, this is the first pair of equal opposite sign, and this is the second. For any quadrilateral satisfying this condition, we can say that this is a parallelogram. So we can say that actually rhombus is a kind of parallelogram. Okay? As a result, goes to the properties of rhombus. As rhombus is a kind of parallelogram, it inherits all the properties of a parallelogram. In addition, you can observe that by property of parallelogram, you know that the diagonals bisect each other. So the four triangles here actually are congruent. Therefore, we have the following 2 properties. The first one, the diagonals perpendicular to each other. And the second one, we have 2 sets of equal angles. The first one, these 4 angles, and the second one, these 4. 2 sets of equal angles. To use all these results, you may use the recent property of rhombus. Let's see some example. Example 8 in your textbook. Okay, we have a rhombus, we have 2 diagonals, and we need to find out the value of m, x, y, and z. M first. Okay, M represents the length of AB, which is a sign of the rhombus. So by definition of rhombus, you know that all 4 sides are equal, so M should equals to 5. The first part about M. And then the second one about X. X is the angle made by 2 diagonals. So by the property of rhombus, we know that this must be 90 degrees. So property of rhombus and then 90 degree, this part. And then the third one, to find out the value of y. You may focus on this triangle. Oops. You may focus on this triangle. In this triangle, we know that the value of x is 90 degree. We know the 70 degree. So by angle sum of triangle, you can find out the value of y, which is 20. And finally, the value of z. Similarly, by property of rhombus, we know that this angle equals to this one. Means the value of y and z are the same. So by properties of rhombus, you can find out z equals to 20 degree. So an easy example. And then goes to example 9. So this time you have a rhombus again. You know that the perimeter is 104. And then you know that AE equals to 24 cm. The first one, find BD. Okay, perimeter equals to 104. So we can find out the length of a sine of rhombus by dividing 104 by 4 equals to 26 cm. This is by definition of rhombus, as we know that all 4 sides of the rhombus are equal. Okay, so this is 26 cm. And then you can focus on this triangle. This is a right-angled triangle. By the property of rhombus, we know that, okay, this is a 90 degree. AEB equals to 90 degree, this one. in a right angle triangle, we have the length of the hypotenuse, which is 26, and the length of one of the side, which is 24. So by Pythagoras theorem, you can find out the length of ED equals to 10 cm. Finally, BD. By property of parallelogram, or you may say the property of rhombus, the length of BE equals to the length of ED here. So this is 10 cm and this is 10 cm. Therefore, BD, the whole length is 20 cm. Okay, this is part A of this question. And we may go to part B of this question. Find the area of the toy. We don't have a general formula for the area of the rhombus, but actually you can cut it into two triangles. Cut in two triangles and focus on the upper one. In this triangle, we have the base. We can make use of BD to be the base, which is 20 cm from part A. And the corresponding height is AE, as they made a right angle here. So for the area of triangle ABD, we can calculate it by 1/2 times 20 times 24. And we know that the triangle ABD actually equals to the triangle CBD. They are a pair of congruent triangle, or you can say that BD acts as the axis of symmetry of them. So just multiply the area by 2. So this is the area of triangle ABD. It is the area of the whole rhombus. Okay, and then we can go to rectangles. I know that you have so many properties of rectangles. For example, 4 90 degrees, opposite side equal, so on and so forth. But actually, mathematically, we usually use this one as the definition of rectangle. Means when you have any quadrilaterals and you find that the 4 interior angles are all equal, we can say that this is a rectangle. Okay, this is a rectangle. Also similar to rhombus, we can find that, okay, for any rectangles, actually we can find two pairs of equal opposite angles. This is the first pair and this is the second pair. So actually we can say that this is a parallelogram again. So we can say that any rectangles is a kind of parallelogram, just like rhombus before. Okay, any rectangle is a kind of parallelogram. Okay, let's go to the properties of rectangle here. As any rectangle is a kind of parallelogram, it inherits all the properties of parallelogram first. And we have 4 equal interior angles. And you know that the sum of all interior angles of a quadrilaterals may be 360. So divided by 4, we know that is 90 degrees. So you have 4 90 degrees here. And then the third one, all the two diagonals are equal, as you can prove that actually. Okay, this rectangle is congruent to this one. So you can see that two diagonals are the corresponding sides, so they're equal. And finally, the diagonals bisect each other. You can combine the result of these two. From the properties of parallelogram, you know that the diagonals bisect each other, and from the properties here, this one, the two diagonals are the same. Combine them together, you can get the fourth property of rectangle. So to use any fact here, you can just make use of one reason, property of rectangle. Easy. Okay, example again. This time we have a rectangle. You have two side length 4 and 3, and then find out the length of BE. Find out the length of BE here. Okay, this is half of the diagonal. So in the textbook you can see that, okay, this is a rectangle, so we know that this is 90 degree. This is 90 degree, and then we can see that, let me use blue. This is 90 degree. So you can see that, okay, triangle ABC, this one is a right angle triangle. right angle triangle, make use of Pythagoras theorem again. So you can see that AC, the whole diagonal here is 5. It's 5. And then by property of rectangle, the two diagonals have equal length. So another diagonal, this one, BD equals to AC equals to 5 again, equals to 5. Just like this one. And then once again, BE is half of the diagonal. So half of the diagonal, this is from the property of rectangle. So divide by 2, so you can see that EB equals to 5 over 2 or 2.5. No units for any length in this question, so no need to give it a unit. So this one, and then another one. Example 11. This time you have two quadrilaterals in this question. ABCD is a rectangle. This one, ABCD is a rectangle. And then we have BCED is a parallelogram. This one is a parallelogram. Okay, so be careful. Okay, the first one, we have to find the length of AC, where AC is the diagonal of the rectangle. Okay, so let's see. In this question, we have only one side length, which is here, 10 cm. So we try to relate AC with EC. AC is one of the sign of parallelogram. So you can see that AC should have the equal length with BD. And then BD is also the diagonals of the rectangle. So by property of rectangle, they should have the equal length with AC. So the problem is solved. And write down your solution like this. Okay, the first one, explain why AC equals to BD by property of rectangle. And the second one, explain why BD equals to CE. This is from the opposite sides of parallelogram. That means 10 cm. So finished. And then part B. This time, find angle AEC. This one, AEC. This one. So let's see. For the angle, we have only one angle here, 126 degrees. So we try to relate the required angle with the given angle 126. So the first one, you can see that this is an isosceles triangle. By property of rectangle, you know that OA equals to OB, just as mentioned in this line. So in an isosceles triangle, you know that, it mentioned this one. So let's follow the solution from the textbook, never mind. Okay, by property of rectangle, you know that OA equals to OD. This is an isosceles triangle. So from this isosceles triangle, you know that, okay, these two angles are the same, base angle isosceles triangle. So this one and this one. And then you can see that the two marked angle here and 126, they have the relationship of exterior angle of triangle. So you can calculate that. Okay, the sum of these two angles equals to 126. So you can calculate that each of them equals to 63 degrees. This is 63, and actually this is 63 degrees also. And then finally, we have to find out AEC. Since that one is a parallelogram, we have these two sides are parallel to each other. With the transverse, so AE, we can see that the angle AEC and angle ADB makes the corresponding angles. Okay, so by using this reason, we can find that AEC equals to 63 degrees. Okay, the third one, square. Square, a very beautiful quadrilateral. For square, actually the official definition is we have 4 equal sides, the first criteria, and 4 equal interior angles, the second criteria. Just like we combine the definition of definition of square. Actually, we combine the definition of rhombus and also the definition of rectangle becomes the definition of square. Okay, so actually we can see that square is a kind of rhombus, or we can say that square is a kind of rectangle. As a result, for the properties of square, easy to remember, it inherits all the properties of rectangle and all the properties of rhombus. And also one more thing, you can see that the 4 little triangles made in the square, all of them are congruent, and actually all of them are isosceles triangle and right angle triangle. As a result, we can calculate all the base angle of them should be 45 degrees. To make use of any facts related to square here, we can just use this recent property of square, easy to remember, and goes to some examples again. This is a square, and we know that AC equals to 2, so this is 2, the whole length, be careful, the whole length is 2. Find BE, find BE. By property of square, you know that, okay, actually, the diagonals have the same length and bisect each other. So EA, ED, EC, EB have equal length. So by property of square, we can say that, let me write this way, one by one. AE equals to EC. Just mention this two first. They have the same length because we just make use of this two side. AE equals to EC. The whole length is 2, so divided by 2, so we can find that only one of them, AE equals to 1, AE equals to 1. And then the second step, as AE equals to 1, we can further say that, okay, AE actually equals to BE also. Similarly, property of square, so BE equals to 1 again. Part B, find the perimeter of square. You may leave the radical sign in the answer, so you can expect maybe you have to use Pythagoras theorem. This is the reason why maybe you have the radical sign, right? Okay, so AC equals to 2 here. This is 2 again. And you can say that we have some right angle triangle, so Pythagoras theorem again. The length of AB equals to the length of BC. So I mentioned an example, a solution different from the textbook, never mind. Okay, focus on the textbook. In your textbook, it makes use of this right angle triangle. Okay, in part A, we calculate the length of BE and also the length of AE. So this is 1 and this is 1 again. And this is right angle, property of rectangle or property of square. Okay, so make use of this right angle triangle. You can calculate that, okay, the length of AB is square root of 2 by Pythagoras theorem here. Okay, one length is square root of 2, so the perimeter 4 equal length, so 4 times square root of 2. Okay, next example again. This one a bit complicated, quite long. Okay, this one. You have a square, ABCD is a square. Okay, by the definition of square, we know that these 4 sides should have the equal length, so I color them in red. And then we have that angle at 68 degree, and CE equals to ED. CE equals to DA. DA is colored here, is colored as red, so I color CE as red also to indicate that they have the same length. Okay, find out X, Y, and Z. After coloring, you can find that actually triangle CBE is an isosceles triangle. Okay, so you may explain first using this part. Explain first why are they isosceles, and then since they are isosceles, you know that, okay, this angle is blue equals to this one. Both of them are 68 degree base angle isosceles triangle. And finally, make use of angle sum of triangle. You can find out the value of X, which is 44. Okay, so a twist here is after coloring, you can see that, okay, actually triangle CBE is an isosceles triangle. Then you can do the following. Similarly, for Y, actually after coloring, you find that triangle CDE is an isosceles triangle again, as CD and CE are colored as red. So this is an isosceles triangle again. Sorry. And this one, this is not, maybe I rub off them first. So color them as red. Okay. By property of square, you know that this is a right angle. So the whole angle here should be 90 degrees plus 44, which is 134 degrees. So, and this is an isosceles triangle, so this one should equals to this one. Both of them are y. So you can list an equation y plus 134 degrees equals to 180. As a result, you can calculate y equals to 23 degrees. So actually, in your book, do the similar things like this. Y equals to 23 degrees. And then finally, to find out the value of z. As you remember, in property of square, we know that the whole angle here is 45 degrees. And from the front page, we find that the value of y is 23 degrees. So just take the difference and you can see that the value of z is 22 degrees. Okay, we finished 3 of them, and finally we have the remaining 2. For trapezium and kites. Trapezium and kite. Trapezium first. For trapezium, be careful. Let me find a ruler. Can I have any ruler here? Okay, for trapezium, the definition of trapezium is if we only have one pair of parallel opposite sides. Okay, because you know that for adjacent sides, it can never be parallel to each other. We can say that this is a trapezium. So actually, when you want to construct a trapezium, you may make use of ruler and draw any two parallel lines, first, and pick any 2 points from each parallel line and join them together. Again. Difficult for me to use a ruler on iPad. Okay. So pick any 2 points and then directly join them together. You can see that this must be a trapezium. Okay, this one is a trapezium. Or actually, this is a usual kind of trapezium we will see. Actually, I can try to draw some more. Okay, a pair of parallel lines. Pick some points. Wait. Wow. Actually, this is also a kind of trapezium. Be careful. Whenever we satisfy the condition, we have a pair of parallel lines in this quadrilateral. No matter we have other 2 sides like this or like this, we can say that both of them are trapezium. Okay. So come back here. We have some special name of some special trapezium. We have 2. The first one, if the transversal here form right angle with the 2 parallel lines, we can say that this is a right angled trapezium. Or if the 2 transversal joining the parallel lines have equal length, okay, you can say that equal length. Then we can call it is an isosceles trapezium, just like the concept of isosceles triangle, but this time we have only a trapezium. For an isosceles trapezium, we have some more properties. You can see that these 2 angles are the same, and these 2 angles are the same. Sorry. And the reason behind, you can try to figure out yourself. Or for me, I will explain this way. You may try to add one more line which is parallel to CD here, and you can see that by corresponding angle you can move this angle here, and A, B, C, D, E, E, and A, D, C, E actually form a parallelogram. So you can see that AE equals to CD. Finally, we can see that AB equals to AE. So we can see that triangle ABE, this one, is an isosceles triangle. So for isosceles triangle, you must have two base angles are the same. So the problem is solved. Similarly, for this two green angle, and also one more property is that the diagonals of the isosceles trapezium should be the same, because you can prove in this way. After you know that some angles are the same, you can show that these two angles actually are congruent. So you can prove it by yourself. Okay, some more properties about examples of trapezium. Okay, this one, we have a trapezium, and read carefully. Okay, the trapezium with this pair of parallels and also these two sides are equal. So actually this is an isosceles trapezium, and we have some angles. We have to find out the value of x, means angle SQR. So for an isosceles trapezium, you know that this angle actually equals to this one. So this one equals to 86 plus x degree also. So by using angle sum of triangle in this triangle, you can find out the value of x. Okay, angle sum of triangle to find out the value of x. Okay, finally, kite. For definition of kites, actually you have two pairs of equal adjacent sign. This is the definition of kite. This time, not opposite sign. Instead, it is adjacent side equal. Just one pair, and the other one. Okay. Okay, let's see some properties of the kites. Okay, we have many three. The first one, we have some angles equal. The first one, these two are equals. As you can see that for the kite, actually, we have two diagonals, and for the diagonals AC, this one, it acts as the axis of symmetry of the kite. It cuts the kite into two equal halves. So by symmetry, you can see that angle ABC equals to angle ADC, and actually these two triangles are congruent. Okay, rub it off. Okay, this for the first property, these two angles are the same, and also these two are the same, and also these two are the same. Okay, this is the first part. And the second part, OB equals to OD. For the two diagonals, only this one is bisected by AC, okay? And the third one, the two diagonals are perpendicular to each other also. And for the above three results, you may use property of kite to explain it. So, should be last example here. You have the kite here, and it tells you that which pairs of sides are equal, and find out the value of x and y. Okay, this is a kite. So we can see that angle here should equals to this angle. Both of them are x. This is my property of kites. And then consider the kite, all the interior angles are known. So we can make use of angle sum of polygon to find out, to set up an equation and find out the value of x, which is 130 degree. This one. After finding x, you can see that x and y lies on the same straight line. Just use adjacent angles on the straight line. The sum of them equals to 180 to find out the value of y to be 50 degree. So the problem is solved. Okay, so finally for this one, a little summary for section 7.3. In this graph, you can see all the quadrilaterals we mentioned in chapter 7. And the notation on them actually represents the definition of that quadrilateral. For example, for parallelogram, the definition of parallelogram is opposite sides are parallel. So it just write down This one indicate that the opposite sides are parallel. Or for rhombus, for equal sides, you see that we only indicate that the four sides are equal. So the notations here just mentioned the definition of the quadrilaterals, but not the properties. And actually the arrows there shows the relationship between them. But I would like to have some amendment here. I will cross out this angle, this arrow. And redraw it like this. Okay, goes to here first and then goes to here. So let me explain to you. Okay, for any quadrilaterals, if we specialize in we can specialize in two different ways. One is if we add the condition for two pairs of adjacent sides equal, you can have a kite. Or if you specialize it in another direction, we just add the condition. We have one pair of parallel opposite sides, we have a trapezium. And if we further specialize it to two pairs of parallel opposite sides, we can have a parallelogram. And then for parallelogram, we can also specialize it in two different directions. If we add the condition for equal interior angles, we have rectangles. Or if we specialize in another way, add the condition for equal sides, we have rhombus. Okay, actually for rhombus, we can result in a rhombus in two different ways. One is we can specialize the parallelogram with the condition for equal sides. Or in another way, for a kite, start from a kite here. Originally, for a kite, we have only two pairs of equal adjacent sides. If we further specialize it to four equal sides, we can also result in rhombus. So you can see that we have two arrows pointing to rhombus. And then finally, for square, if we combine the definition of both rhombus and rectangle, we can have a square. So actually, this figure, we shows the definitions of the 6 kinds of quadrilaterals you learned, and also the relationship between them. Okay, so this is the end of this video, and after you read this video, I think you can finish the self-assessment booklet, the booklet given to you before the holiday for section 7.3, and then take some pictures and then hand in to your teachers. Okay, bye bye.